In our next lesson, we have something called the mean absolute deviation. Now, if we take the first letter of each word, we get the MAD. So to shorten this, we're going to call it the MAD because you're going to see pretty quickly that this isn't a difficult process, but it's a long process. And so it kind of makes us mad. So that's why we shorten it to that. Now, what is the MAD? Well, the MAD represents the average, oops, spelled that wrong, the average distance each data point is from the mean So basically, if we find the average of all of our data set, which is our numbers, we're going to figure out how far apart by the distance is each of those numbers from the average. So we're going to figure this out, and we're going to remember this by creating the mean sandwich. Now, unfortunately, our sandwich is pretty boring. It's going to consist of a piece of bread at the top, which we're going to call the mean. We have our meat, which is going to be our difference. And then we're going to have our bread, which is the mean again. So again, pretty boring, no condiments, no nothing. And we're going to eat our sandwich in a new way. Normally, we would eat it so we get all the parts, but we're going to eat the top piece of bread, then we're going to eat the middle, then we're going to eat the bottom piece. So this is going to be step 1, step 2, and step 3. Just a fun way for us to remember how to do this. So here is the table. Is going to show us scores of 10 people in a dartboard game. So we're going to do those 3 steps. We're going to find the average, we're going to subtract, and we're going to find the average again. So I'm going to label this as step 1. So we're going to find the average of these numbers. So I'm going to take them and add them together. Now, you do want to show this because if you get any part of this wrong, you'll be able to receive partial credit. So we're not just going to stick it all into the calculator. We're going to write down exactly what we're doing. So I have 54 plus 40 plus 69 plus 49 plus 73 plus 42 plus 35 plus 60 plus 51 plus 57. So those are the numbers in the box. And then I'm going to divide by how many numbers I just added, which was 10. Now, because this is a lot of numbers, just like I suggested in the other video, you probably want to put that into the calculator more than one time. So you should have gotten 530. When you divide that by 10, your average is 53. So on average, these numbers are around 53. Now, step 2, I'm going to create a chart. So I'm going to need a little bit more room. So I'm going to come off the side here. So step 2 was the meat, which is the difference. So I'm going to take each data point here, and I'm going to subtract it from this number here. Because we're talking about distance, we know that distance is never negative. So if you subtract and you get a negative number, you're going to turn it into a positive by taking its absolute value, because that distance can't be negative. So start with your data points. So the numbers from the box, we're going to put down here. And then the mean, which was 53, so I'm going to write that down next to each number. So these two are probably the easiest parts because we haven't done any math yet. Now I'm going to go ahead and subtract. Remember, it's the distance. So if you get a negative, we want to switch it to a positive, because because distance is never negative. So this is what I care most about from this chart, is those differences. Now I'm going to take those differences and I'm going to find the average of those. That's going to be my step number 3. So all of these numbers here, I'm going to add together. So when you add those together, you would get 96. So my answer is 9 6/10, and our label is going to be units. So what this means is, on average, each one of these points, which was the scores of a dartboard game, on average, these scores are 9 6/10 units away from the average, which is 53. So if you have a large MAD, then that means that your data is more spread out. If you have a small MAD, it means that the data is closer together. If you have an outlier, that will skew your data a little bit. It'll make it seem like the data is more spread apart, when in reality, that number that doesn't quite belong is going to kind of alter it just a little bit. So what does this mean? Exactly what I said. The average distance between each data point and the mean is 9 6/10 units. And this interpretation will be the same for each of these problems. So you have one to try on your own, just one, but you're going to follow your sandwich. So find the average, find the difference, find the average of those differences. So go ahead and pause the video and give that a try. So for step 1, when you found the average, you should have gotten 17. For step 2, here are your differences. Remember again, we don't want a negative because it's the distance. Each of these data points is from the mean, so we want this to be positive. So we're taking these values and finding the average for step 3. So step 3, I'm adding them together. I got 34, divide by 10, and it's 3 4/10. You aren't going to divide by 10 every time. It just so happened in these 2 examples, there were 10 data points. So then what does it mean? This is the average distance between each data point and the mean is 3 4/10 units. So this MAD is smaller than the first example, so we can imply that the data is closer together than it was in that first example.